Let's solve LeetCode 739 daily temperatures. Given an array of integers temperatures represents the daily temperatures, return an array answer such that answer at I is the number of days you have to wait after the ith day to get a warmer temperature. If there is no future day for which this is possible, keep answer at I equal to 0 instead. As an example, we have input temperatures is equal to 73, 74, 75, 71, 69, 72, 76 and 73. The output is this. Why? Because to go from 73 to 74, which is warmer, we have to wait 1 day. To go from 74 to 75, we have to wait 1 day, which is warmer. To go from 75 to a warmer temperature, it will not take us 1 day because there's a drop in temperature, it's getting colder. It's not 2 days either. It's not 3 days either. It's actually 4 days that we have to wait to get a higher temperature. For 71, it's again 1, 2. We have to wait 2 days to get a higher temperature. For 69, it's just 1 day because we suddenly get 72. And then after 72, it goes to 76. And we only have to wait 1 day. There's no higher temperature than 76, so that's 0, and there's no higher temperature after 73 because that's the end of our input array. So that's 0 as well. Essentially, every last element is going to be 0 because, well, essentially probably the world ends over there. So yeah. Now that probably doesn't do us any good. How are we going to solve this problem? So what I'm going to do is, let's say, copy this thing. I'm not going to use this 30, 40, 50, 60 because it's quite straightforward. It's monotonically increasing. That's not very good. Like a very good example. It's good that it's increasing, or probably not. I don't know. But either way, how do we solve this problem? So if we get 73, I can check 74. Okay, so if I'm on I can check I plus 1 to get to know if the next temperature is higher. If I'm on 74, I can check I plus 1 again. On 75, I have to check I plus 1. Nope. I plus 2, I plus 3, I plus 4. That means for every temperature, I'll have to go and check rest of the elements. And if we are lucky, our next element will itself be the higher temperature, but in the worst case it can be miles apart, or it can be days apart actually. So yeah, and that approach would be O of n square, because for every temperature we have to loop through the rest of the array. So that's not an approach we can use. We can get it done by just using one, like instead of doing an O of n square approach, we can do it by O of n. We only have to iterate over this array once. Well, how do we do that? So let's think about it. So if I'm on 73, I get 74. So that's done. Cool. So if I'm on 74 and I get 75, that's done. Cool. If I'm on 70, or actually, if I'm on 75 and I get 71, I'm not done. I have to look forward. And when I'm on 71, I have to look at 69. 69 is not higher either. But when we reach 72, 72 is higher than 69 and it is also higher than 71. So what we can do is remove these two instantly. As soon as we see 72, we'll remove 69 and then we'll look a bit more down previously in the array and we'll see 71. We can remove 71 as well, right? So what I can do is track two things. Instead of just tracking the number, I can also track its index. So this is index 0, 1, 2, 3, 4, 5, 6, and 7, correct? So what I do is 75, 2 here, then 71, 3 here, and 69, 4. And then when I go to 72, I know I'm on index 5. So as soon as I see that, hey, 72 is greater than 69, I can just do 5 minus 4. So you only have to wait 1 day. The same goes for this thing, 72 and 71. We just see 5 minus 3. So you have to wait 2 days. But when we compare 72 and 75, well, it's not working out. So we have to just say that, hey, sorry, 72, you'll have to wait here. And then we go to 76. 76 is at index 6, 72 is at index 5, and 76 is greater than 72. So we just do 6 minus 5, which will equal to 1. And then for 75, what we can do is, well, 76 is greater than 75, so we can do 6 minus 2 equal to 4. And that gives us the appropriate number of days. So if you're understanding what I'm doing here, I'm essentially maintaining a stack. The stack contains all of the temperatures that have yet to be found like a higher temperature. Essentially, here we are just storing all of the variables where the higher temperature is not found. So for example, 75 was present here. We don't have a higher temperature in the next of the array until here for 75. So it will remain in the array. The same goes for 71, 69, and well, 72. As soon as 72 comes along, this is removed, this is removed. So essentially maintaining a stack where we maintain the temperature as well as the index of the temperature. Where does it exist in the array? So let's go ahead and solve this. It's quite straightforward, right? We can just do for temperature in temperatures, and I told you I need to access the index as well. So I can just do for I comma temperature in enumerate temperatures. So I go over the index and the value at that index, and then I can also create a stack at the top, right? Then the very first thing that I want to check is that, hey, listen, is the stack present? If the stack is not present, I'm wasting my time. So if the stack is present and the stack at -1, because I want to check the last element, right? Because when I'm on 69, like if I'm on 72, let's say I'm on, my I is 72 and I'm storing 69 comma, let's say this was index 4, I believe, or 5, I don't remember. So what we're doing here is calculating the last element of this array and comparing it with the current value at I, right? So that's what we're trying to do as well. And since we know we are going to store not just the value, we are also going to store the index that's present. It's going to be a tuple, right? So we want to extract that tuple. So stack at -1 will give me the last element, which is going to be the tuple. And then I access the very first index. The very first index will give me the temperature, because I'm going to store it as 4,69, not 69,4. But if you want to store it that way, completely up to you. It doesn't really matter. But I would like to follow the convention like this, where I comma temperature is found. So at index 0, there will be the index, and at index 1, there is going to be the temperature. And then what I can do is that, hey, if the stack is present and the stack at -1 at index 1, which is the temperature present in the stack, if it is less than the actual temperature, so what we're trying to compare is 69 being compared to 72. Or let's start from the very beginning, we'll put 73 in the stack, right? So if 73 is present in the stack and 74 comes along, then we just compare 74 and 73, right? So this would be 0,73, and we just compare these two things. So essentially, like, that's what I'm trying to do. And once we have done that, what I want to do is stack.pop. So stack.pop will give me the index, and that is the index that's stored here. So 4,69, 4 would be the index, and the temperature of the previous day, which I'll store as temp. And then what I want to do is create a result variable. So I'll just create a result variable at the top. And for the result variable, what I'm going to do is result at, let's say, this particular index. Okay. I don't want to store it at I want to store it at index. The reason I want to store it at index is because I want to fill the void. So essentially, I want to go ahead and update the result variable at index 4, because we finally found out that a higher temperature exists and I only have to wait 1 day for it, right? So I'll go to that particular index, the index 4, because the answer that we got, let's say 72 is at index 5. So 5 minus 4, the difference of these indexes is the value that should be stored at index 4, because we have to wait for 1 day to go from 69 to a higher temperature. So here I'll just do I minus index, okay? I being the bigger value and index being the smaller value. And yeah, if this happens, this is the case. And irrespective of that, we can append to the stack I comma temperature. Correct? Because no matter what happens, I'm going to go ahead and append to the stack. So when I first start, 73 will be in the stack. Then I compare it with 74, and yes, 74 is a higher temperature. So we pop this off and then we append 74 into this. Then we find 75. The same thing happens for 75 here. And then 75 remains there. 75 does not find a higher value than it. So 71 is appended. 71 does not find a higher value than it. So 69 remains. And now 72 comes along. 72 compares with 69. It is a higher value. Then 72 also needs to compare with 71, right? So what I need to do is, instead of using an if condition, I'll do a while loop. So instead of just checking with the previous stack element, what I can do is compare this with every element, because it can be the case that 72 is a higher temperature than 69. It is a higher temperature than 71, and possibly also a bigger element than, let's say, any other element that was present here. For example, 70. 75 is not. So once we reach this condition, it checks with 75. It's not. So the while loop breaks out and these two are popped off. 72 comes within the array. Then 76 comes along, and 76 is greater than 72. It is also greater than 75. So both of them are popped off and 76 remains in the array. Great. Also, now that 76 is present in the array, what I want to do is compare with 73. Now 73 is not bigger than 76, so 73 and 76 both are in the array now. Okay, by array I mean the stack. Now what do? We can't update their result variables, right? So what do we do after this? Well, the answer is that we can just do result is equal to 0 if it's not specified, and we'll set 0 to everything. Okay, so for this example, we set all of the elements until 76, but for 76 and 73, it will remain 0 because this condition was not triggered. So the index was not updated. So result will remain 0 like this. Cool. After that, we can just go ahead and return the result. We'll run this and I believe this will work out. Yep. And I'll submit. And that works out. The time complexity here is O of n, because I have to loop through every single array and find out, every single array as in, there's only one array, but I have to loop through every element in the array and I'll get the response. So that's O of n. And for every element, there's a potential that I also have to check the stack. So that can add some contribution to this. But as you can see, this is already pretty congratulatory. Okay. And the memory here is 26.4% beats, but either ways, it's like the memory here is O of n because we are having a stack here and we are also maintaining a result variable here. So obviously it's going to be O of n.